2017 Leaving Cert Higher Level, Paper 1, Question 7. Population of cities. So it's one of the long questions. Sapphire City, the population over time is SE to the power of 0.1t by 10 to the power 6. We should know that 10 to the power 6 is a million. And Avalon, the population over time is Q of t is equal to 3.9 e to the power of kt by 10 to the power 6 again. We're told that t is the time in years and t is equal to 0. Very important, the initial time. T is equal to 0 at the beginning of 2010. The population in Part A of Sapphire City at the beginning of 2010 is 1.1 million. Find the value of S. Well, that's when t is equal to 0. So t is equal to 0. So we have S e to the power 0 by 10 to the power 6 is equal to 1.1 million. Now I could write that as 1.1 by 10 to the power 6. And you can see here, if I divide across by 10 to the power 6, e to the power 0 is equal to 1. So I get S is equal to 1.1. Part B, you're asked to find the predicted population in Sapphire City at the beginning of 2015. Well, that's 5 years hence, so time is equal to 5. So we have Sapphire is SE, when we have S, 1.1 e to the power of 0.1 by 5. You could just write 0.5 by 10 to the power 6. So this is just calculator use. You can type this directly into your calculator. And you're going to get an answer of 1,813,593. Nice easy calculator use in Part B. In Part C, find the predicted change in population in Sapphire City during 2015. We have the population at the beginning here, so we just need to get the population at the beginning of 2016. So that would be 1.1 e to the power 0.6. We're going to put 0.6 in for t, or you could write 0.1 times 6 by 10 to the power 6. We type that into a calculator, and we're going to get 2,004,330.68. But I'll round it off to 331. And then we're going to take away the previous answer, 1,813,593. And that was rounded off slightly too, and that's going to give me an answer of 190,738. Part D. Part D, the predicted population in Avalon at the beginning of 2011 is 3,709,795. Write down and solve an equation in K to show that K is equal to minus 0.05. Correct 2 decimal places. Avalon, 3.9 e to the power of kt by 10 to the power 6. 3.9 e to the power of kt by 10 to the power 6 has to be equal to 3,709,795. Dividing by 10 to the power 6 and 3.9, well, that will make the top, the decimal is going to end up in here. So I'm going to get e to the power of k times 1, because it's the beginning of 2011 in 1 year, is equal to 3.709,795 divided by 3.9. Now we could use log or natural log here, so I'll do the natural log first. The natural log of the right hand side, it's e to the power of k is equal to 3.709,795 over 3.9. So the natural log of that right hand side would have to be equal to k. The natural log of 3.709,795 over 3.9 is equal to k. So k is equal to minus 0.04999 minus 0.04, and few nines there, good few nines, and it's correct to 2 decimal places, minus 0.05. If you prefer your log rules, you can say k times the log of e is equal to the log of 3.709795 divided by 3.9. Just make that decimal clearer. So k would be equal to the log of 3.709795 over 3.9 divided by the log of e, which gives obviously the same answer. So k minus 0.04. There's 1, 2, 3, 4, 5 9s and a 34. We don't need them because it's two decimal places, but k is equal to minus 0.05. So logs are natural logs. You can choose which one to use. Part E, we're asked to find the year in which the populations will be equal. So we have 3.9 e to the power, we got k minus 0.05t by 10 to the power 6 has to be equal to, just double check, it was 1.1 e, 1.1 e to the power 0.1t, 1.1 e to the power 0.1t by 10 to the power 6. Well, we can cross out the 10 to the power 6's. So we want numbers on one side and e's on the other. So if I divide across by 1.1 and also divide across by e to the power minus 0.05, I'll have this one will be left here, e to the power 0.1t over e to the power minus 0.05t. So this is the rules of indices. I won't bother simplifying this. We can simplify it at the end here. 3.9 over 1.1. If I bring this power up, it becomes positive. So I end up with e to the power 0.1 plus 0.05 t. So that's going to give me 3.9 over 1.1 is equal to e to the power of 0.15 t. And again, I can use my natural log or log rules here. I'll get the natural log of 3.9 over 1.1 is equal to the power of the other side, which is 0.15t. So rather than simplifying it down too early, we can just say t is equal to the natural log of 3.9 over 1.1 divided by 0.15. Just double check this on a calculator. Gives 8.437. Oh, we just need the A part. So that's 8 years after 2010. We're asked for the year in which the population will become equal. So it would have to be 2018. 8 years after 2010. Part F, we're asked to find the predicted average population. So this is average value in Avalon from the beginning of 2010 to 2015, and this is this formula 1 over b minus a. So we know, we can see here b minus a, rather than putting in 2025 and 2005, this is a 15-year window that we're looking at. So we're looking at 1 over 15 by the integral of, just check which one Avalon was, it was the 3.9 one, wasn't it? Avalon, 3.9 e to the power kt. So 3.9 e to the power of k we got as minus 0.05t by 10 to the power of 6 dt. That's what we have to integrate. So there's going to be two parts of it. So we can take the 10 to the power of 6 out and just bring it back in at the end. It might be the easiest just to tidy this up a bit. So we're looking at 1 over 15. If we integrate 3.9 e to the power of, we have an a in here, so it's 1 over a. So 1 over minus 0.05, and then the 3.9 e to the power of minus 0.05 t doesn't change, and I should have put my integral values in here. It's a 15-year period, so between 15 and 0. So just tidying this up, we have here by 10 to the power of 6. Just leave that out. So 1 over 15 by 1 over minus 0.05, 3.9 e to the power of minus We're putting in the 15 first, so minus 15.5 is 75, 0.75. And then we're going to have minus in this case. So we're going to have a minus, and then it's going to be 1 over minus 0.05. E to the power of it's going to be 0. So let's have a look at what this gives us. Don't forget my 3.9. Just put a bracket around that. And by 10 to the power 6. Just let me see my, tidy this up a bit first. So 1 over 0.05 is 1 over, it's 20. There's 20, 0.95. So minus 20 times 3.9 e to the power 0.75 minus 0.75, and then it's going to be plus e to the power 0 is equal to 1, so it's just plus the two minuses, this one and this one, 3.9 over 0.05. That's going to give me on a calculator 41.155. Don't forget this 10 to the power 6. So if I divide that by 15, I get 2.743693. Is that enough numbers for millions? 939 by 10 to the power 6. To give me 2.743694. This 9 is important in this question, so we have to go 1, 2, 3, 7 decimals in this case to get the exact answer. Part G, we have to find use the function q of t is equal to 3.9 e to the power of minus 0.05 t by 10 to the power 6 to find the predicted rate of change with this differentiation of the population in Avalon at the beginning of 2018. Okay, so q prime t when t is equal to 8. Q prime t is equal to, so rather than 1 over 8, a e to the power of at, so it's going to be minus 0.05 multiplied by 3.9 e to the power of minus 0.05 t by 10 to the power 6. And if we put 8 in here, it's just calculator use, minus 0.05 by 3.9 e to the power of a 5s are 40 minus 0.4 t, no, minus 0.4, we put t in as 8 by 10 to the power 6. And typing this into a calculator, we get a minus number, minus 130,712. That's the end of the population question.